Hello, ladies and gentlemen. Welcome to another tutorial. It's the first one in nearly a year. I'm not going to go into why, but yeah. I'm going through and redoing some of the ones that have got really, really bad audio. There is going to be some static clicking, and that's got more to do with this delightful program, which is also dealing with all the noise removal. But anyway, so what we want to do, I've set up a map with some cubes. These are all 100 centimeter cubes. This grid is 100 centimeters wide, and these are scaled differently. These cubes are also same size. They're scaled differently. One's 0.5, one's at 1, and one's at 1.5. But this is 3 cubes inside of an actor, which I've got here, which I've made just for this demo. So what we're going to do is we need a line trace, which I've already made, and then we want to take out hit component from that line trace. We're going to go get component bounds. Now this isn't going to work necessarily as you'd expect straight out, because there's a couple of little hitches with this. What we're going to do is we're going to print it, print the value, what we're going to do is we're going to go to 0.1. Let's make it a interesting color that you can actually see. Oops. And we're going to not print it to the log. So what we're going to do, we're going to take the box extent and just plug it straight in, and you'll see something in a minute. So starting at this one, you can see size 50 by 50 by 50. Now, problem is this cube is not 50 by 50 by 50. As you can see, it's 100 by 100 by 100. It's still got its physics attached to it, and it's 100 high. This one is 106 by 106 by 75. So that's not right either, because this cube's the same size and it's 75 by 75 by 75. So what's happening here is this what it does is it draws a envelope around the cube. It goes all the way around there, always aligned to the world that you're calling it in, or the level of world that you're calling it in. So what we need to do is we need to, well, for starters, we need to scale this up properly. We need to actually get it correct. And we need to multiply these values by 2 so that it starts representing things properly. It's the same thing here. 75, 50, 25, 25, sorry, 34.151. That one's 102 by 102, 68 by 68, and these are all in the actor, like in their own little actor there. So, okay, so how do we fix this? Well, first off, we need to multiply these values by 2. And then off you go. So now we're reading the correct heights. That's 202 wide. Well, yeah, because that's 100. That's 100, and it's another 12-ish. So yeah, that all makes sense. So how do we get the values with taking into account the rotation? Well, what we've got to do is we've got to call this against a reference to one of these. Now, we can get that by casting to the static mesh that is the component. And it's actually a different node. So what we're going to do, we're just going to shove that aside. What we're going to do is we're going to come off out hit component. I'm going to cast to static mesh component. I don't really like to do the casting thing, but in this case it's workable. Now from here, if it's successful, we want to print. We want to append our result. We want to display it properly. About 2 P's. Append. Okay. Put size in there. Let's change that again to red. Okay. So that's just going to display. It's going to display more or less the same thing. Instead, what we're going to do is we're going to get from here, coming off the cast, we're going to do get local bounds. So straight away, we've already got a problem. This is relative to the origin of the static mesh, which isn't too bad. We've basically got to run this through the absolute node and then add that to that, and then multiply it by the scale. You want to add that to that. Last time I did it, we didn't have that node. Okay, so we've now got those two together, and we're just going to spit them into that. So let's go and have a quick look. So 100 by 100 by 100, 100 by 100 by 100, 100 by 100 by 100, and you'll notice it's giving me the right value even though it's twisted around. And we can even knock it around a bit to there we go. Now bear in mind the scale is not applied here. So these are all the same cubes. They're all 100 by 100 by 100. So now we need to apply the scale. Now, with get world scale, this is relative to the world space in the actor. So because we're casting that static mesh component, it is relative to this. So what we're going to do is we're going to take that, multiply that, there and there. So now we're taking the size, the unscaled size, modifying it, so multiplying it by the scale of the mesh or the component, and now we're printing it out. We got 100 by 100 because that's got no scale to it. 150 by 150 by 150, same result there. This one's 50 by 50 by 50 because that's scaled at 0.5. That one's scaled at 0.1, so at 1 because it's 100 by 100 by 100. And that one's 150 by 150 by 150. And we get the same result on these. So that's how you do it. As far as applications, well, yeah, there are a few. Anyway, like and subscribe. I'm doing a few more later on. Yeah.